f of x equals negative x over x plus 1. Perfect. Or of course you can write it as they did, like this. That's fine too. Both are correct. Okay, so in this problem we are asked to follow the 7 steps and graph everything, right? Graph the function and determine everything. Okay. How do I start? What is the first step? That is important, but not the first priority. Find? Right, but even that, before that, you're right. It's connected to what I'm going to say. Exactly. So first I have to find the domain. What is the domain of this function? Exactly. Negative infinity to negative 1, union negative 1 to infinity, and I will get my chart going. So it's negative infinity to infinity. Negative 1, 0 has to be in the chart. And since I know that x cannot be negative 1, I will already write it's undefined there. If it's undefined at that point, and that x plus 1 does not cancel with an x plus 1 from the top, what does this mean? It's definitely a vertical asymptote. Very good. X equals negative 1 is a VA. Once I say that I know that that's a VA, I know that left and right must be what? Indeed. So what I don't know is the sign of these infinities. But they must be infinity because otherwise this will not be a vertical asymptote. It will be an open point, right? So how do I determine this? You can punch it in the calculator if you want to, but it's not that difficult to say negative 1.1 and negative 0.9. With negative 1.1, put in the function at the top, negative with negative will be positive. So then the top will be positive. That's all you need. You need the sign. Negative 1.1 plus 1 will be negative. So then positive over negative is negative. Now I plug in negative 0.9. With minus in front is still positive. But negative 0.9 plus 1 will be positive. So therefore on this side the sign is positive. Now let's plug in 0 so I can determine the y-intercept. When x is 0, y is 0 because it's 0 over 1. Correct. Very good. 0. Now I would like to determine the end behavior. And in order to determine the end behavior, I have to think in terms of the type of function. Is it type 1 or type 2? It's type 1 because it has the same degree over the same degree. Therefore, the horizontal asymptote must be, careful, yes, negative 1, which is the leading coefficient of the top, over positive 1, which is the coefficient of the bottom. So then y equals negative 1. Y equals negative 1 is the horizontal asymptote. Actually, I'm done. Yes, I will discuss the symmetry, but everything else is done, right? Yes.
Test-wise, do you want us to solve for the symmetry if there's no symmetry?
So that's the only thing that I wanted to write right now. So f of negative x will be negative x over negative x plus 1. The top is x, the denominator is negative x plus 1, and if you factor out negative 1, you will write this. So the function does not equal f of x, f of negative x does not equal f of x, and it does not equal negative f of x. Therefore, this function is not symmetric. Any questions so far? Now, all I have to do is follow my chart and graph the function. So I have to graph a vertical asymptote at -1, and I have to graph a horizontal asymptote at -1. Ready? Yes? Okay, so here's what my chart tells me. It says, from approaching -1, which is the horizontal asymptote, it goes down to -infinity on the left-hand side of the asymptote, of the vertical asymptote. From approaching -1, it goes down to -infinity on the left-hand side of the vertical asymptote. On the other side, I have to have this point, which is 0, 0. On the right-hand side of the asymptote, I see positive infinity. It comes down to 0, 0, and further down towards -1. So from positive infinity, it crosses at the origin, and it approaches -1 as x approaches infinity. So this is our function, -x over x plus 1. And yes, you can graph with the graphing calculator to check. Daniel, is this better? Okay. So domain is crucial, x and y intercepts, but once the function passes through the origin, there is nothing else. So even if you set it equal to 0, you will still get x equals 0. So there is nothing else. Very good question. Anything else? Yes, please.
Page 490, number 62.
62, 490. Is this a homework problem? I posted homework. That's okay. I posted homework, and I said either today or Monday. It's up to you. Okay, 62, 62. 62, very good. So 6, natural log of 2x equals 30. Very good problem. I was going to start with chapter 4 anyway. Someone emailed me a homework. I have graded your homework. I'm returning it today. And I did not write the name, and the person did not have the name on it. Anyone claims this? Okay, let me know. Okay, so what is the first step we need to perform here? This is towards solving for x. Thank you. Okay, so what is the first step, please? Anyone? I will be in deep trouble if I did that. Say it again. No. Say it again.
Make both sides long.
No.
Divide by 6.
Absolutely. I have to clean it up, dividing both sides by 6. So this, thank you. Natural log of 2x equals 5. Now I know that a cleaned up log equation can be replaced by, always, by yes to the yes equals indeed. So final step, x will be, I forgot to mention that 2x has to be greater than 0 because that's the domain of this log, which means x must be greater than 0. If we don't get a number that is positive, we'll have to disregard it. Okay, so then how do I solve this equation for x? What do I need to do now? I just got rid of the ln. I'm not going backwards, right? This is just a number. So in order to solve this equation, I need to, of course, that's all I want you to, that's all I want you to say. So of course this is a positive number. If you want to approximate it, you will grab your calculator, you will raise e to the 5th power and divide the answer by 2. So e to the 5th power, and then I divide everything by 2, and I got 74.2. You can plug it back in to check the solution. Good. Very good. Perfect question. Anything else? Okay, I would like you to choose an example of a problem from here now. So use the definition of the logs to solve for x. So we can choose anything you want from here. And look how important the domain is. My department worked very hard, and they put like 15 problems in here, or 12, only on the domain of the log function. So I want you to choose from here.
From 15 and 16, you said? Or-
Yes, yes,
We do see on number 15?
yes. On 15, this one?
Yes.
Perfect, excellent. So we have log base x of 8 equals 3/2. How do I convert this into something I can solve? Right? Right? Very good. So now, how do I solve this? So what does 3/2 mean? X to 3/2.
Take the third half.
So it's the square root, right? The square root of x to the 3rd, which is 8. Good. How do I solve this equation? I know we solved them 2 months ago, but we have to remember. But this is right. Very good. So then I have x to, what do I have on the left? Yes, on the right hand side I have x to the 4th, but what do I have on the left? Very good. Very good. Now, before we analyze this equation, can anyone remind us what x can be?
Anything greater than 0?
But not 1. Remember, it's the base. So for the base, there are 2 options. The base can be greater than 1, or the base can be between 0 and 1. So it has to be a positive number and a real number. So what should I do now to both sides in order to get x? Very good. The cube root. So how much is x then?
X.
Is 4. Very good. So I go back and check. 4 raised to 3/2 equals 8. Let's check. 4 raised to 3/2. Does this equal 8? Of course it does. I have to check because I squared both sides, right? So this is the square root of 4 to the 3rd, which can be rewritten as the square root of 4 everything to the 3rd, which is 2 to the 3rd, which is 8. So I know that x equals 4 is the only solution. Any questions? Okay, anything else from 15, or we move on to 16? Okay, 16. G, it's a good one. Very good. So we have g of x. Oh, you said G. I'm sorry. You said G or J. For some reason, I looked at J. I looked at this G. So do you want this one? Okay, perfect. H of x. Not that it matters. The name doesn't matter. Log of x squared minus 3x plus 4. Very good. So then, what do I need to do? Oh, let me read the question. Find the domain of each function. Write the interval notation. Okay. So what do I have to write? Say it again. In order to find the domain, I have to write something and then solve that. Very good. Log cannot be applied to a quantity that is not strictly positive. Very good. Now you're right. I'm going to factor. If I can. But if I cannot factor, if this polynomial is not factorable, because I see f4 and 1, and then I have -3, so obviously, unless I copied it incorrectly, let me look again. No. I copied it correctly. X squared minus 3x plus 4 has to be greater than 0, but I cannot factor. But it doesn't matter. I can still find the solutions with the quadratic formula. Very good. So I have x squared minus 3x plus 4 equals 0. I write this only because I'm showing that I'm using the quadratic formula, but I'm not changing this into this. No. So x equals -b, which is 3, plus or minus b squared minus 4ac divided by 2a. So from here, I know that x equals 3 plus or minus the square root of -7 over 2. So what can you say about these solutions? Imaginary numbers, so I'm going to say not real. So then what does this mean concerning this inequality? The fact that the solutions were not real, what does this mean? First, say it again.
It's not really true.
Careful. So if you were to graph this, how would you graph it? Does it have a minimum or a maximum? It's a quadratic function. Does it have a minimum or a maximum? Minimum. So, and since it does not cross the x-axis because the solutions are not real, what is the sign of this function always? Right. So this is always positive. No matter what I plug in there, it will always be positive because this is a quadratic function that opens upward and it never touches the x-axis. It's way up. So what will you say about the domain of this function? Right. Exactly. Because that condition is fulfilled forever. Very good. Good. Next one. And then I'd like to go back to chapter 4 at the end of chapter 4. This one, last one. Perfect. Okay. So we have h of x. Any questions on the previous problem? Okay, h of x equals log base 7 of 2x to the 4th plus 14x cubed plus 20x squared. Again, the same question. I'm asked to find the domain of this function. What do I have to write and solve? Say it again. Yes. 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 Very good. Very good. Okay. So then I'm going to try to factor this polynomial. Okay. Is there anything that I can pull out right away? X squared. Very good. And what is left in parentheses? Yes? No, it's still 14. We only took x squared. That's okay. And plus 20. I'm sorry? Why we took out?
Can you factor out 2x squared or 3x squared?
Oh yes, actually I can. You're right. Absolutely. I was daydreaming. Of course. The wise thing to do is always to factor out the greatest common factor. Thank you. My mistake. Okay, so now this is much easier to factor. How will you factor this?
X plus 5, X plus 2.
Is this inequality chart ready? In case you like the chart. Yes. So we have X. I will not put 2 in the chart, of course. It's a factor that doesn't have to do anything to X with X. X squared is one factor. X plus 5 is another. Yeah, but you can divide both sides by 2 and 2 is gone. And X plus 2. And the product. X squared, X plus 5, X plus 2. Okay. So can you please tell me where, so X is the variable in the problem. And now, what values of X I have to put in the chart? For this one, good. For this one, good. In order from left to right, I should put what first? The next one. And then, good. There must be a 0 somewhere for X squared. Under,
0.
perfect. There must be a 0 somewhere for X plus 5. And there must be a 0 somewhere for X plus 2. What will happen to the product when X is negative 5? Good. What would happen to the product when X is negative 2? And finally, when X is 0. Perfect. Can anyone give us the sign of X squared? Always. Very good. Very good. Can anyone give us the sign of X plus 5 and X plus 2? Negative first and then positive. And the other one, the same thing. Negative first and then the positive. All positive. So I see that there are 3 subintervals. 1, 2, 3, 4, I'm sorry. 4 subintervals. And what is the sign on the first one? Good, excellent. What is the sign on the next one? What is the sign on the next? And on the next? Perfect. So finally, I can write the domain of this function after all this work. Brackets, parentheses. Excellent. Union.
-2 to 0.
Very good. Parentheses or brackets. Union.
And then 2 to infinity. I mean 0 to infinity.
You understand that we had to exclude the 0, right? Because at 0, this will have been equal to 0, and that is not allowed. Very good. Look at all this. All this work was done just to find the domain of this function. Good. Now the answer should be in the back. I think. Again, I did not participate. Yes, the answers are all here. So I highly recommend do all these problems. Please, do all these. The answers are in the back. Okay, we are finished with the handout. And now I would like to go back to the last section of chapter 4 and then go backwards. Okay, I would like to look at another, let's say, logistic function. I'm looking at the review, actually. It starts on page 510 and it ends on page 513. All these problems have the answers in the back. Yes. Yes. I'm sorry, I didn't see you.
For the homework, you gave us numbers 82 and 86, and that's slant asymptote problem.
You don't have to do that.
I was just making sure.
Yes, thank you. Thank you for reminding me. Yes, if you're asked to, because they removed it. Yes, thank you. So you don't have to graph the functions with a slant asymptote. I did not show you in class, so you're exempt of that. Good. So let's start with a word problem. 86 on page 512. According to the U.S. Bureau of the Census, in 2000 there were 35.3 million residents of Hispanic origin living in the United States. So in the year 2000, I'm taking notes, 35.3 million. In 2010, the number increased to 50.5. Use the exponential growth function. Can anyone remind us the exponential growth function of t equals a0 is the notation, yeah, the initial. Very good. E raised to kt. Although they are giving us, which we already knew, they are saying this is a of t that you should use. Can anyone give us the a0? Right, 35.3, exactly. 35.3 times e to kt. Very good, excellent. Find k correct to 3 decimal places. So that's our first question. Find k correct to 3 decimal places. So basically, this was already used, done, because it gave us the 35.3. What I did not use yet is this information. And we are told, I just want to see if I got it. T years after 2000. Yes. So can anyone give us this point? 10, comma, 0.5. I need to plug this in this function. So I need to replace a of t by 50.5, and I need to replace t by 10. Can anyone dictate? That's the point that I'm given. Can anyone tell us what to write? Which is?
No.
This is the y, and this is the x. 50.5 equals 35.3 times e. Right, I'm going to write 10k, or is the same thing. Good. So I'm given this, actually, and I'm asked to solve for k. How do I solve for k?
We're gonna divide by 35.
First step, I have to clean it up. You already said that, yes. So 50.5 divided by 33.3, 35.3 equals e to 10k. Only now I can apply natural log, and I will. So natural log on this side and natural log on this side. So then the left-hand side, keep it as is, 50.5 over 35.3 with log in front. But what will you write on the right-hand side? Exactly 10k. Finally, k equals Can anyone tell us what to write?
15.5 over 35.3 divided by 10.
Very good. So then natural log in parentheses, which pops up with it. 50.5 divided by 35.3. Close the parenthesis and further divide by 10. And it says correct to 4 decimal places. 0.0358. So K is 0.0358. Now I have to rewrite the function. So A of t equals, what do I write? 35.3 times e raised to 0.0358 t. Remember, this is the independent variable. I have to have it in the problem. Okay, that was part A. Use the resulting model to project the Hispanic resident population in 2015. So this is part A. Now in part B, we are asked to determine the population using the model we have. So how do I determine that?
A of 15.
A of 15, very good. So A of 15 is 35.3 times e to 0.0358 multiplied by 15. So please give me a number. And I'm putting my attendance in. And there is part C.
60.39.
How much?
60.39.
60.39 million. Do we all agree with that?
Yes.
Okay, here's the last part. In which year will the Hispanic resident population reach 70 million? What am I doing now? Say it again. Good. I have to find the time when the resident population is 70 million. So what do I have to do? Please dictate. And I'll write it. Equals
35.3.
excellent. Perfect. So John, Rebecca, Charles, Ted. Perfect. So, what do I have to do first, please? Exactly. So then I have 70 over 35.3 equals e to 0.0358 t. Okay, now what? Apply. Okay, so apply natural log to both sides. The left-hand side is natural log 70 over 35.3, and the right-hand side will be 0.0358 t. And then, who can give us t? So t will be natural log of 70 over 35.3 divided by this. So with a graphing calculator, so I have natural log, oh, I don't need that, natural log, 70 divided by 35.3, and I divide everything by 0.0358. And I get 19. What does 19 mean? Yes, since, so that would be year 2019. Very good. Any questions on this problem? Any questions on this problem? Okay, now let's look at some equations. Log equations and exponential equations, other than what we just saw here. So still on page 512. Let's choose between 74 and 78. 74 and 79. Please choose an equation. Page 512, 74 through 79.
78.
78. Good. So that is natural log x plus 4 minus natural log x plus 1 equals natural log x. What is the first step, which I highly recommend? I recommend you state the domain. I truly believe that. So for this, what will you write? What is the domain of this?
X is greater than
I have to write inequality first for everyone to see, though. What is the domain for this?
X greater than
X plus 1 must be greater than 0. And what is the domain for this?
X 0, 0.
X greater than 0. Strictly, log cannot be applied to 0. So then from here, I know now that x is greater than, perfect. From here, I know that x is greater than, right? And from here, I know that x is greater than 0. So you can graph all this if you want to, but here's my explanation. The first one is from -4 to infinity. The next one is further to the left, to your right, from -1 to infinity. And the next one is further to your right. It's from 0 to infinity. Where do these three overlap?
0 to infinity.
So I'll say the domain is 0 to infinity. And if I don't get a solution that is strictly greater than 0, I will say, sorry, it's not a solution. Okay, now let's look at the left-hand side. The left-hand side has two logs, and they are subtracted. Yes, so please tell me how to condense this side.
X plus 4 over X plus 1.
Close.
LA.
Aha! X plus 4 over x plus 1. It will be a terrible mistake to write this. Natural log of x plus 4, everything divided by natural log of x plus 1. This will be a terrible mistake. So please pay attention to that. I'm not saying you are going to make this mistake, but I'm just saying this is log applied to a ratio. It's not a ratio of logs. I'm not saying you said that. I'm just pointing it out. Okay, good. So what do I do now? I don't want to see like something like this on a test. Like you're simplifying ln. You cannot do that. This is not what we're trying to do. So here's the concept. Two logs in the same base are equal. What has to happen to the quantities that they are applied to? One more time? Yes. So two logs in the same base, if it's not the same base, I cannot conclude that. So two logs in the same base are equal. What has to happen to the quantities that they are applied to? They have to be equal to each other. So therefore, x plus 4 over x plus 1 must equal x, and I'm going to write it as x over 1 for you to get a hint. So what is it? Right. So that's what I wanted to suggest. So then x plus 4 must equal x squared plus x. One more time, x plus 4 must equal x squared plus x. So now what?
Everything equal to 0.
Why? Excellent. Why? Because this is
A ratio.
a quadratic equation. The equation is quadratic. I have to set it equal to 0. However, I noticed something that simplifies my life completely. I can subtract x from both sides. So I should have, as you said, set it equal to 0. But since those two terms go away, I have an easier method now. What would be the method that I should apply?
Square.
Take the square root. So then x equals, careful,
Plus.
Plus or minus.
plus or minus 2. Of course, when I look at the domain, I will say, no way, only x equals 2. Okay, we talked about domain. We talked about condensing and expanding. Do you think we need another exponential equation? Yes? Okay, the most difficult one is 72. It's not difficult. But I say that because it has many steps though. 3 raised to x plus 4 equals 7 raised to x 2x minus 1. We looked at something similar last time. What do I do? Yes? Can I present 3 and 7 with the same base? No. So then what should I do?
X plus 4 equals 2x minus 1.
I cannot because they are not the same base.
Could you put that-
I can't because 3 and 7 cannot be presented with the same base.
you can, use natural.
Natural log, yes. Natural log to both sides. And now I have to be very careful what I write and how I write it. Can anyone dictate the next step?
Parentheses, text.
Exactly. Exactly. And parentheses 2x minus 1 natural log 7. Indeed. Indeed. And now, what am I trying to do?
Divide ln.
I will not divide. It's not a mistake, but it's way more complicated. I will distribute. I will distribute to these two terms, and I will distribute to these two terms. So x natural log 3 plus 4 natural log 3 equals 2x natural log 7 minus natural log 7. Now I realize that there are two terms with x. And there are two terms without x. So how do I continue? What should I do? Absolutely, absolutely. So x natural log 3 minus 2x natural log 7 equals minus 4 natural log 3 minus natural log 7. Excellent. Perfect step. Now what do I do next? I'm ready. I should combine, division is always at the very last step. Say it again. Factor out x indeed. Natural log 3 minus 2 natural log 7 equals negative 4 natural log 3 minus natural log 7. Finally, I have x. After all this work, all these steps, I have x. Can anyone dictate? Negative 4 ln 3 minus natural log 7 divided by natural log 3 minus 2 natural log 7. No one can simplify this any further. Do we understand this equation? Every step? Okay, let's go from the beginning one more time. So 3 and 7 cannot be presented with the same base. If 3 and 7, if I were able to present them with the same base, then it will be a very straightforward equation. But I can't. So therefore, I have somehow to bring the power down. There is only one function that allows me to bring a power in front as a factor, and that is natural log or common log. Once I get to this step, so first of all, it has to be in parentheses. Otherwise, I will only multiply natural log by 4, and I will not multiply it by x, right? So that's why it has to be in parentheses. Now I distribute to these two terms. I distribute to these two terms natural log 7. And then I realize that these two have to be on one side and these two have to be on the other. Here I look Well, I can combine them. They're not like terms. Because this is natural log 3 and this is natural log 7. But I have a way of solving for x by factoring out x. X times this is this, x times this is that, right? So this is just a number. So therefore, in order to get x, I divide this by this. Is that okay? Better? Okay. I'd like to go back to, so do you think we need more problems or more work in chapter 4, or should we go back to chapter 3? Because I would like to review a little bit of.
How do you determine which one goes on the top and which one goes on the bottom?
When I solve an equation.
No, the
So-
last step.
Okay, so here's a question. If I have 2x equals 4, which one goes at the top and which one goes to the bottom?
The 4 goes at the top.
Right. So since it's x multiplied by a number.
Oh, okay.
Clear?
Mhm.
Good. So should we go back to chapter 3 or should we still stay on 4?
Can we do a few and three?
Yes. In 3 we have inequalities, and I think we have that chart, and I think that that's good enough, right? We know inequalities. Yes? So I'm sorry?
Can we graph inequality?
You're not supposed to, you're not going to graph this. This is what I mean by inequalities. Right? You don't need to graph that. Is there a way of graphing and solving it? Yes. So if you want to use that method, that's fine too, but there is no need. I think that that's even more work. So let me just summarize what you should expect on this test one more time. From chapter 3, you should expect quadratic. You should expect third degree, fourth degree polynomial. They're all the same. 5th degree, 7th degree is the same with this. 8th degree, 6th degree is the same with this. You should expect a rational function. And you should expect an inequality. Now, the inequality may not be by itself. It may be in the form of what we just did, find the domain of a log function that uses a inequality. In chapter 4, you should expect a graph of a log or exponential. You should expect equations, exponential and log equations. And you should expect a word problem. I can't think of anything else. Now, please tell me what you would like to look at.
About word problems in chapter 3.
Yeah, the only problem that that you can see in chapter 3 is using a quadratic.
Right.
So if you want to start with that, that's fine.
I didn't know if those would be on the test. So word problem
Yes.
in chapter 3 would be on the test.
Yeah. So let's look at problem 7. Should I do that as problem 7 or not? 7 on page 435. A quarterback tosses a football to a receiver 40 yards downfield. The height of the football, f of x in feet, f of x in feet, is given by negative 0.025 x squared plus x and plus 6. Where x is the ball's horizontal distance in yards from the quarterback. So this is in feet, but x is in yards. Part A. What is the ball's maximum height, and how far from the quarterback does this occur? What do I have to find?
Yeah.
Which is given by?
Negative is big negative be.
Exactly, the vertex. Just, I saw it in your homework. When you graph the polynomial function, you graph an axis of symmetry. There is only one function that has an axis of symmetry. One, just one. Which one is that? Right, quadratic. Only the quadratic function has a vertical asymptote. I'm sorry, has a vertical or an axis of symmetry. Just one function, just quadratic. Okay, good. How do I determine the x-coordinate of the vertex? Which is negative, b, which is 1, 2 times a, which is negative 0.05. I already multiplied by 2. So this is 100 over 5, which is 20. And this is yards, because it's x. How do I determine the maximum height now?
Plug 20 into the original equation.
Very good.